In this video, I just want to do a quick review of direct variation, what that's going to look like as an equation, as a graph, and as a table. So on the left, you see I've got a couple examples over here. Okay, so this is our main form, y equals k times x. Remember what that really means is we have y is equal to k times x. K is just some number, right? It's not going to change. So for example, if we come down here, in an equation, you will see that that k will be replaced by a number. So this is direct variation because y is equal to 3 times x. We could also say y is equal to 10 times x. Y is equal to 1/2 times x. It is just y is equal to some number times x. One thing that often confuses students is this is exactly the same as the example below. All we did is we did that multiplication. 1/2 times x can be written as x over 2. And the tricky part is students often see it like this lower example, but have a tough time going in the opposite direction. So going from this and realizing that yes, this is really just the same as 1/2 times x. The other way that this can look is like this equation on the top right. Y over x is equal to k. And we got this equation from the original. These two things mean the same exact thing. All we did is, in this left equation, if you divide both sides of that by x, you get the equation on the right. So again, some examples of that. Y over x equals 7. Y over x equals 3. We can also change the letters, right? You might see instead of x and y, you might see other variables. So we could use a and b. So again, same form. Moving on to graph. So we want to think about this from the perspective of that first equation. So that first equation said y is equal to kx. So y is equal to some number times x. This looks remarkably similar to something else that we have seen before. Y equals mx plus b. Hopefully you remember that this is a linear equation, right? So when you see this, you should be thinking, oh, this is a linear equation. So our direct variation is also linear. Again, these are the same in that they are both linear. However, our direct variation just doesn't have this b, right? So you can think of k is the exact same thing as the slope of a line. That being said, our examples of direct variation are going to be straight lines, like this red one and like this blue one. They're going to be straight lines that, very importantly, go through the origin. Remember, the origin is that point 0, 0, right at the center of a graph. Finally, as a table, so this is an example of a table that is a direct variation. We want to think of, again, this same equation, noticing how all of these things are related. If it is direct variation, our variable y will be equal to some number times x. You'll just have to find that number. So in this situation, our y values down here, we can say, okay, well, if I have an x, my x is 1, what do I need to multiply that by to get 3? And we notice that 1 times 3 would give me 3. If x is 2, I need to multiply that by 3 to get 6. 3 times 3 is 9. 4 times 3 is 12, and so on all the way down. So if that is true, that there's this connection between x and y, such that each y value is equal to some number times x, then it is direct variation. And more importantly, that number that we're multiplying by, so for example, that number that we're multiplying by is 3, that means that that k value is 3. So in this particular situation, for this table, our k value is equal to 3 because every y value is equal to 3 times the x value.